Thanks for the introduction. So this is joint work with Nathan Fadjian. So Nathan and I have been sort of pulling a bit of data from PyPI over the last few months and trying to figure out what's going to happen with Python 2 and Python 3 and whether the sort of schism is going to be sort of addressed through the natural processes. There's some various sort of lessons I've learned while writing the future package, which I'd like to share with you as well about. So in terms of it, sort of, a perspective on how to upgrade a platform. So Python is a platform in the sense that people build on top of it. That's what I mean by platform for the purposes of this today. So it's about how to upgrade or how not to upgrade a platform. And this might apply to web APIs or to any API in code or anything like that. Okay, so this is a few steps. So I think this is the right way to do it. First of all, you choose a new interface for if there's some old interface, you choose a new interface. Next, choose a new name for that new interface. Okay, so what's it going to be called now? And it should be called something different. Okay. After that, you want to keep around old and new interfaces in parallel for a few versions. And then we want to deprecate the old interface and keep it around. Or we can deprecate it straight away, but we keep it around for several versions. And then we remove it eventually when we're done with it. Okay. So this is pretty simple. I think if we follow this recipe, we can upgrade a platform quite smoothly for users. Okay. All right, so now there's this rule. If you break something, change its name. This is something that I think is key to this process. And it's something that was followed partly in the Python 2 to 3 upgrade and partly not. And I think the reasons, those instances where it wasn't, was the cause of the majority of the problems with compatibility that we're seeing. Okay, so here's a quote from Guido back in 2007. Okay, those warts that can be fixed without breaking compatibility are getting fixed in an evolutionary way, but some things just can't be changed that way. Right? So he started thinking about Python 3000, probably sort of around the turn of the century. And there was a mailing list formed in March 2006 for discussion about what should go into Python 3. And this continued with sort of active discussion from the core developers on lots of different features of the language and what should happen. Continued until Python 3 was released, which was in December 2008. Okay, so there was a period of 2.5 years, and this was sort of getting toward the end of that period. A period of that time when everything was up for discussion. Okay, so here's an example. It's a little photo of a whiteboard during one of the sprints after a PyCon in the US. And this was just sort of shows the sort of depth of changes or the scale of changes that the core developers were willing to make to Python at that time. Okay. Now, the main reason that's given nowadays, the main reason that Python 3 is sort of considered so that it's considered to be worth it is Unicode. All right. So the idea was that Unicode couldn't be upgraded. Well, the strings couldn't be upgraded as smoothly as we might have liked. But I'll come back to this point in a moment. So the end result is that Python 3 broke our code. So in the Python 3 release notes, it was here, right, December 2008, you'll find that Python really hasn't changed all that much. By and large, we're mostly fixing well-known annoyances and warts and removing a lot of old cruft. Okay? That was the end result of 2.5 years of extensive discussions on everything, that Python 3 should be and shouldn't be. But so it sounds very harmless, doesn't it, from that? But this omits that backward compatibility was broken, which is the reason that 5 years later, over 5 years later, getting up to 6 now, that its adoption is still slow. Now, Armin Ronica is quite a colorful character, and he likes talking and blogging about Python 3, and he writes, so he's the author of Werkzeug and Flask and various other packages that deal with the interface of bytes and text, but he's sort of probably the most vocal person in the community about so his opinion that Python 2 is the better language in some ways. So, but essentially there's this interesting comment here. This stuff really confuses beginners and so on. So there's this, the debate's not really over in a way, but the horse bolted sort of almost 6 years ago. So, and Alex Gaynor weighed in on New Year's Eve. There's a bit of sort of controversy, I suppose unrest due to the fact that most of us aren't benefiting yet from Python 3, and we'd like to. So Nathan and I did some data mining. I guess it's a fancy term. We sort of looked at some stats that we pulled from PyPI and to try to work out whether Python 3 is going to catch up. Is it just a matter of time? Or does something big need to be done to change the current trajectory? So these are the results we got in terms of the we started collecting data about 3 months ago. And it's not a lot of data, just 3 months, but we can draw some conclusions from it, perhaps. This is the absolute package count, the difference in absolute number of packages between today and where we were 3 months ago. And we see it's not, according to this, it's not the case that Python 3 is catching up yet. Okay, the difference is growing. It's getting wider. Now, this doesn't mean it will continue. Maybe the second derivative of this is larger, and maybe this is going to overtake it at some point. That's what we can all hope, and I think that's what we should be working towards. But right now, it doesn't look to us like this is sort of cause for optimism. Now, so I suppose one thing is that these are sort of statistics from PyPI using the classifiers, and those are quite dodgy. So what we took was the max of the number of packages labeled Python 2.7 and those labeled Python 2. And actually, Python 2.7, there are many more packages labeled 2.7 than Python 2. Go figure. So. And with Python 3, it's the opposite situation for some reason we can't discern. So there are many more packages labeled Python 3 than any of 3.4, 3.3, 3.2, 3.1, 3.0. So anyway, we took the max in both cases and just compared the maxes for the number of packages. So this is what we see at the moment. So it's not catching up yet in absolute numbers. Okay? So we also looked at the difference in relative terms, and Python 3 is growing faster than Python 2 there in relative terms, which is a good thing. It's a start. Okay? So anyway, now Guido said at PyCon that he's still optimistic that Python 3 is going to, that the situation 5 years from now is going to be a lot better than it is today with Python 3 adoption. He did say, he said several times over the last 5 years that he's optimistic about this. So is he right to be optimistic? Yeah, let's come back to that. So now there's this topic of sort of pragmatism versus idealism. So here's an interesting photo. But there's this, so Joel Spolsky, who's the author of the blog Joel on Software, he wrote a long time, I think it was 2004, although that may be slightly dodgy, that date, but he wrote about the Raymond Chen camp versus the MSDN camp within Microsoft, and the kind of difference in philosophy that these two groups had, and the effect that as it was playing out within Microsoft. And he wrote this: the victory of the idealists over the pragmatists at Microsoft directly explains why Vista is getting terrible reviews and selling poorly. So he called the Raymond Chen camp the pragmatists, very strict about backward compatibility, doing a great job of that. And the MSDN camp, which was keen on sort of, I suppose, changes that were more far-reaching. yeah, probably the idealists more. Now, I would say perhaps the victory of the idealists over the pragmatists in Python directly explains why Python 3 has slow adoption. I think Python 3 is, so as we saw from those release notes, it's really not a pragmatic upgrade, or wasn't back sort of, I guess a lot has happened since then that's good, but 3.0 wasn't an upgrade driven by pragmatism, except from the perspective of the developers in making the code base easier to maintain for the long term. So that's interesting. Now, I'm going to go through some things about Python, the good, the bad, and the ugly, as I see it with the Python 3 upgrade, just very briefly. So first of all, the good, I think these things were handled well. Okay? So the fact that the raise now takes an exception object without the comma, that old syntax. Here, accept this with an as part of the syntax. That's good. I think these things were all handled well because they were designed to be the way things work in Python 3, and they were backported nicely to Python 2.6 and 2.7. And so Python 2 evolved in the right direction, in a backward compatible way. So I think in all these instances, the evolution was handled well. So also the fact that there's an explicit operator now for integer division, and that's been around for a while. Octals, that's made less confusing. Instead of just a 0, that's good. And the fact that this has turned into a function rather than a method call is more consistent with the language, the rest of the language. So I think all those are good instances of this evolutionary process. And now, more good instances, I think this was done well. It's done for the right reasons and backported to Python 2.6 in the right sort of way. There's this new I/O module available in Python 2.6 and 7, which does just what it does on Python 3, and it's still available in Python 3. That's great. So we can use sort of this nice open function with an encoding argument and a nice bytes I/O object and things like that. So just as we can in Python 3, these are all handled well. Decided to move reduce to the functools module. And that's fine because it was actually backported, unlike sys.intern, for example. And these help with forward compatibility. How are we doing for time? Keep going. So 15, okay. All right. So the bad, I mentioned sys.intern. This was, intern was moved, but this isn't available in the sys module in Python 2. It was just forgotten, presumably. So the new interface wasn't backported. Now, this isn't possible in Python 2 either. It's been this nice reorganization of the standard library, but this wasn't really backported into 2.6 and 2.7, and it would have been so nice. In hindsight, we can see, if we'd been able to sort of access, especially like urllib.request, it would have just made so many code bases able to use the new idioms, which are sort of available in Python 3, and without then having this kind of incompatible code, because the Python 3 wasn't designed to be compatible. It really wasn't kind of on the radar initially. But anyway, these could have been backported. All of the new standard library modules reorganized. They could have been just aliases introduced, but they haven't been. I think this wasn't handled well. Range is an old name and a new meaning. So that breaks that rule before. These methods could have been backported, but haven't been. So we're stuck with next in Python 2.6, which requires some less than ideal hacks to kind of enable 2.3 compatible code. And this is a nice idea in some ways. This future built-ins module, which is available in Python 2.6, perhaps 2.7 definitely, with various built-ins just as they appear in Python 3. That's good, but this isn't available on Python 3. So it's still not possible to have a unified code base that just sort of imports all of these, expecting them to be the usual built-ins. So that would have been nice. It was kind of done, nice intention, but it wasn't followed through in the sense that Python 3 doesn't have this. And it could have been done. I think that would have made things better. But now the ugly, I think, bytes object, this wasn't backported. It was just an alias introduced to string, but that's very, very, very different from the Python 3 bytes object. So it could have been backported, but it wasn't, presumably because of manpower. Or yeah, but I think that would have been a good thing to ask for help from the community. So if Python 2.6 and 7 had this bytes object just like in Python 3, then we could have code bases migrating much more sort of yeah, steadily to use these new features and to bring it closer. So yeah, I mentioned this before. Now string, I think, is the worst of these probably because it's a new thing with an old name. One thing Jacob Kaplan-Moss said in his talk at PyCon last year, PyCon in Australia, it was that, so when thinking about compatibility, you want to eliminate the word string from your lexicon. And the word text is sometimes used, and Django uses this term text to refer unambiguously to Unicode strings. So perhaps, just perhaps, text could have been the name given to what's now a str in Python 3. And then it could have been introduced into Python 2 as well, maybe with a T prefix if necessary. And we could have had these different string and byte types in parallel. Yeah, but it didn't happen like that. So now a couple of other little things. So exec is a bit like print in that it became a function, but unlike print, there's no future import for it. So it requires a bit of hackery with a module like 6 or future.utils. And metaclasses is terrible in the sense that it's a syntax error on the other language. Whichever language you write a metaclass in, it's a syntax error on the other language. So there's just no way of proceeding any further. And luckily, someone brilliant came up with a solution which was brought into Benjamin Peterson's 6 module a few years ago, which has kind of helped to bridge this gap somewhat. But that could have been done much more elegantly. Okay, so now here are some interesting sort of case studies of other upgrades. Okay, does anyone know this? This is H-Day, Höger Trafikomläggning, something like that. So this was the day when Sweden changed from from driving on the left to driving on the right. Okay, it was a day, the 3rd of September, and this is a picture from that day. Yeah. So apparently at 4:55 a.m., any traffic that was out, and only a small amount of traffic was allowed out on the roads that day, any traffic that was on the roads, cars had to stop and slowly move to the other side of the road. And then at 5:05 a.m., they can continue driving on the other side of the road. So that was how that transition was handled. And despite this picture, it worked really smoothly. There were actually fewer traffic accidents that day than most other days, and that can sort of continue. It sort of built up eventually again to the usual levels after a period of a month or so. But it worked really well. But they had to change the road signs, 500,000 road signs to the other side of the street and things like that. It was a big organized process. Yeah, it's one way to handle an upgrade. Yeah, interesting. It didn't take 5 years or 5 or 6 years like we've had so far. It was all done within 24 hours or even 10 minutes, really. So that's one way to have an upgrade, Global Flag Day. Now, if you use a Mac and yeah, then you might be, you probably use this old MagSafe adapter. Apple upgraded it to this thing which is longer and skinnier and incompatible. Okay? They provided this nice little converter. So that's an option sometimes. I guess I've attempted to do that with the Python Future package to make it this little piece of thing that you can use to glue the old together with the new. But that's one way to handle upgrades, so to provide some adapter interface which works. Now, yeah, this is really interesting. So who remembers this? Yeah, this worked really smoothly. So this was Apple's transition from using Motorola CPUs to Intel CPUs back in the sort of or the early 2000s. Okay, the IBM PowerPC, right? PowerPC to Intel, yeah, yeah. So this is yeah, it worked beautifully. So it's a big upgrade. Somehow they managed to get their developers in the community to just kind of follow the regular process which they laid out. So they organized it very well. It was very smooth, and within a couple of years, people seemed to have forgotten about the old PowerPC architecture, but it sort of still worked for a little while, but gradually it was phased out and seemed to work very well. So this is something we might have had as a model for the Python 3 upgrade process. Yeah, it's certainly possible to do very large-scale, deep-reaching upgrades of technology without it being a problem. Okay, so some comments on the upgrade process. Now, 2 to 3 was designed to be a tool for one-way migration from Python 2 code to 3, and leaving behind Python 2 compatibility. And the original expectation that people would do this was wrong in the case for libraries, at least, because people maintaining libraries had the majority of their users on Python 2 still, so they would need to continue providing compatibility. So this wasn't really the answer for that. So this is something we can sort of learn from. So why was this wrong? We can sort of think about, okay, what can we learn from that lesson? And I suppose it's that a community has mass, and a community won't just do as they're told. They've got what they want to. Everyone has their own sort of reasons for using Python, reasons for upgrading or not upgrading. Now it's this concept of deprecation. This is a brick factory that's deprecated. Okay. And a deprecation just means signaling you shouldn't use this. Now, this poll is deprecated as well. Okay, so it's a concept that exists outside computing. Yeah, it's interesting. We can, I don't know what to make of this, but now forward compatibility is something Python has through these under future imports in particular. There are other instances. Now, backward compatibility is, I think, the more powerful concept. Now, cars, the original cars were horseless carriages. That's where the term car came from. And they were designed not to be twice as wide as a horse-drawn carriage, but about the same width, so they could go on the same roads that horse-drawn carriages were, and they could kind of exist in parallel. So this is, I think this is the more powerful concept. Now here's, I guess we know what this means, that the next version runs the previous version's code. Now with software, that might mean the next version can read the previous version's data. So Microsoft and Apple have worked this out. So the later versions of these Office software packages can read the earlier file formats, but they express a preference to saving files in the new format. And over time, this puts a pressure on the community to upgrade. Okay, it's viral. Here's an example from Keynote. Would you like to upgrade this presentation? So then users of the old version will have this pressure for them to upgrade as well. Okay, so maybe we could learn a lesson from this about how to encourage upgrades. So backward compatibility is, I think is more powerful as a concept than forward compatibility. So that's it. The lessons are that if you break something, change its name. I think this is key. Keeping both interfaces in parallel and the backward compatibility is viral inherently. So yeah, I'm very happy to take questions on either this or my talk from yesterday, because there was no time for that, if you have any questions about that. Thank you. Any questions? Ryan? Yes, okay. Yeah.
How much of this is it too late? Some of those sound like things we could introduce into 3.4 or possibly in a patch release on 2.7, and we would actually then be able to do a lot of this.
Yeah, I think the good question. I think the hardest. I think it's too late in those instances where the name stayed the same but the behavior changed. So for stir, for example, it's too late to fix that without introducing a new thing into both. Something maybe like Python 2.9 and 3.5 could have a text data type if we wanted. I don't think that would be the answer, but it would at least be possible to call it something else. But now for I think backward compatibility is what we need as a community. So if Python 3.5 can somehow run Python 2.x code, then people will start using it, and people will then be able to start writing Python 3 code. And this is going to put a pressure on, a kind of good kind of pressure on the community to upgrade. Yeah, I haven't fully answered your question. I'd be happy to talk to you about it afterwards. Yeah, that's the best I can do. Hi, Tennessee.
Hi, Ed. I was really interested in the kind of package proliferation out of the various versions. Do you think that that's partly because of what operating systems are packaging as default versions, or do you think it's because of people are invested in libraries that are on particular versions?
With the graph that I showed?
Yeah, that's right.
Yeah.
So like a lot of enterprise organizational environments, they might still even be on 2.6, forget about 2.7.
Yeah.
So people might be building for pretty legacy deployments, I guess.
Yeah, and that's okay. So I've heard the core developers, or some of them say that it doesn't matter if some people stay on Python 2 forever. And in a sense, that's true, but it does detract from the value of Python 3 if, for example, Dropbox writes this new JIT compiler for Python 2 only. Well, yeah, assuming it's released, yeah. Yeah, so, but the download counts I showed, what the graphs I showed explicitly aren't for download counts. They're actual numbers of packages with those classifiers. Yeah, Ryan.
So I enjoyed your talk yesterday as well about Python Future, and sort of from what you were showing, it looked like a pretty nice, not necessarily full solution, but a pretty decent and easy to use compromise solution. Is the answer here, it's like, all right, we all just start using Python Future and be happy and we'll all get there together? Or is that not quite good enough for any particular reason?
Well, it doesn't handle C extensions. I think it's a good option. I think so. You asked me yesterday about performance. The range functions are somewhat slow at the moment, but with most of the other functions, there shouldn't be a performance hit because it's just basically a function that exists somewhere else under a different name, and it's been made available under the Python 3 name. So it's now in terms of it, yeah, I think that would be a good thing. It requires a lot of work, though. I think backward compatibility is easier in a way. So I've come to the conclusion that a future package is all well and good, but then trying to get PyPI to migrate to using this is, it's a big effort by a lot of people. And that's forward compatibility. But if there's backward compatibility, like if the past package were made better, or if the sort of auto-translate feature made it just sort of seamless to run Python 2 code, then that would be easier. So I was interested in the lightning talk on the sucks package yesterday. That's an interesting concept. I've considered that idea as well, of running a separate Python process and having some communication. I think it's worth trying all these options, but I think that backward compatibility is the right thing to aim for. And I'm not sure if I've kind of answered your question. Yeah? OK. All right, thanks. Hi, Ron.
Hey, so of all the packages that you mentioned that weren't quite there, future built-ins not being in Python 3 seems like a few minutes fix. So can you comment on why you think it's not there yet? It seems like we could do it tomorrow.
We could, yeah. I suppose it's not very comprehensive anyway. So it provides, maybe about 7 functions or so from memory. And there's no byte type in particular. So I guess the future dot built-ins package I've written tries to provide that in a more comprehensive way. So I think the idea was fine, but it was not followed through consistently, and it's not really a sort of big enough solution. Yeah. Interesting question. Yeah. Hi.
Hi. Thanks for mentioning sucks.
Oh, right.
But the main thing is when I've looked at porting from Python 2 to 3, normally it's the Unicode type thing, which is where you spend most of the time, where you have to actually understand whether you want it to be a string or you want it to be bytes. And it seems far safer to focus on doing the work in Python 3 whenever possible. You get the nice super semantics, etc.
Yeah.
And when you're looking at your code, you're going to need to differentiate anyway with your legacy code base whether these things are Unicode. Otherwise, you're just stuck in Python 2 forever. By the time you've done that work, most of the other problems come out in the wash, or a little bit of using 6. And then for any third-party packages, then you could use sucks if you really had to. But it just feels like Python 3 is a cleaner environment, and one that we should be encouraging people towards.
Yeah, I agree. So yeah, in an ideal world, there'd be people writing code in Python 3 first, and just providing Python 2 backward compatibility, compatibility through some automated tool. I think, Future would do a good job with that. But yeah, I think that's right. It's a good platform to target first, and there's no real reason not to anymore. But for upgrading an existing code base, it's a slightly different challenge. Yeah, but yeah, I agree with your point in general. Yeah.
From anyone that's
all right. Thank you.